Good day, my name is Francisco Domingo Molinaiz. I work as teacher and researcher at the University of Almería in Spain, one of the partners of the TheGreefa project. In the project, I am the person leading the case study. In this model, I'm going to present the case study developed to characterize the greenhouse production in Spain and Italy. The main objective of the case study is to analyze different boundary conditions characterizing two representative European climate regions selected in the project. The first area selected was Spain, with the largest extension of horticultural greenhouse in Europe. In the last year, 2023, greenhouse equipped in Spain more than 77,000 hectares. The second area selected was Italy, with a robust greenhouse industry. This region was identified in the market evaluation as a potential initial market for the climate control system developed in the TheGreefa project. In the year 2023, the greenhouse area in Italy was around 35,000 hectares. Three case studies have been selected in Almería in Spain. The first was the inhabited Almería type greenhouse, naturally ventilated. The second was the inhabited multi-span greenhouse with climate controller. And the last was the multi-span greenhouse heated with natural gas. In the Almería type greenhouse of the University of Almería, two tomato crops developed in the season 17-18 and 23-24 has been analyzed. Several alternatives of crop combination have been grown in inhabited multi-span greenhouse during the development of the TheGreefa project: cucumber tomato, cucumber pepper, and tomato zucchini. Two case studies have been selected in Italy for tomato production: inhabited multi-span greenhouse and multi-span greenhouse heated with natural gas or oil and wood chip. Several sources of information have been used in the case study. The technical characterization of the greenhouse of Almería has been carried out through a survey developed in the year 2022 by the Andalusian Comparative Society, covering about 1.4% of total area in Almería. Production costs of greenhouse of Almería, unheated greenhouse, had been analyzed for 7 different alternatives for crop cycle from the Price and Market Observatory of the Government of Andalusia. Production costs, energy, water, fertilizer, and phytosanitary consumption have been measured for inhabited Almería type and multi-span greenhouse in the greenhouse of the University of Almería for tomato, pepper, and cucumber crop. Tomato production costs for inhabited multi-span greenhouse in Italy had been obtained from the Istituto di Servizi per il Mercato Agricolo Alimentare, ISMEA, and energy and water consumption had been measured by Sfera Agricola, one of the partners of the project, in a commercial heated greenhouse, estimating the associated production cost. Finally, a life cycle impact assessment has been developed estimating the main environmental impact factor for the 5 case study using the Excel EUFOROS environmental simulation model developed in a previous European project. In the case study, the main climatic parameters that affect the development of greenhouse horticultural crops have been analyzed. The installation of the climate control system using thermochemical fluid developed in the TheGreefa project can help to maintain an adequate temperature and humidity to incorporate CO2 from the outside environment and to achieve greater homogeneity of these climatic parameters inside the greenhouse. However, the design of the air distribution system must prevent radiation loss at the crop level due to shading. Although there are multiple options for effective climate control in greenhouse, active systems require high energy use, and passive systems are often limited by the external weather conditions. The use of thermochemical fluid could be used as a complement to other systems in order to reduce energy use. Energy consumption in greenhouse is mainly affected by the need for heating. In unheated greenhouse, consumption varies from 13 to 100 gigajoule per hectare, while in heated greenhouse, the energy required can exceed 20,000 gigajoule per hectare. While in Spain the area of protected crop has increased up to 18% in the last 7 years, in Italy the area occupied by greenhouse remained very stable. The price of horticultural products have significant variability depending on weather conditions in Europe or factors that affect marketing at the COVID of the Ukrainian war. The highest prices were achieved in both Spain and Italy in the year 2023. In general, sales prices are between 15 and 20% higher in Italy than in Spain. For each of the 5 selected case studies, production costs, water and energy consumption, and their environmental impact have been analyzed. The results obtained for each of the 5 case analyses are presented below. The first case analysis is the Almería type greenhouse, which accounts for more than 70% in Spain. Its investment cost is about 15 or 20 euros per square meter. With this type of greenhouse, growers in Almería obtain productivity normally lower than 15 kg per square meter, with production costs of 0.7 to 1.0 euro per kilogram. Depending on the price of each year, farmers can obtain a profit up to 15,000 euros per hectare or obtain loss when the price of the production is lower. These greenhouses are those that require the less energy consumption, mainly in the irrigation system and the opening and closing of the windows when they are motorized. Electrical energy consumption varied between 1 and 1.5 kWh per square meter, and water consumption varied between 15 and 75 liters per square meter. This greenhouse produced the lowest environmental impact. The structure of the greenhouse and the irrigation system generate the greatest impact. The value calculated for the 2 tomato crops developed in the University of Almería greenhouse are similar to those published by several authors, with the emission between 95 and 218 kg of equivalent CO2 per ton of product. The second case study is the unheated multi-span greenhouse that represents around 2% of the greenhouse area in Spain. The cost of this type of greenhouse varied from 25 to 39 euros per square meter. In this greenhouse, production rather than 15 kg per square meter can be achieved, depending on the combination of crops. Production costs vary from 0.5 to 1.5 euro per kilogram, corresponding to 50 or 100,000 euros per hectare. Higher investment costs make it difficult to obtain profit if products are sold to the average price. Normally, farmers with this type of greenhouse tend to obtain better sale price of their production through direct contract with distribution companies. For this type of greenhouse, electrical energy consumption is very similar to the Almería type, varying between 1 and 1.5 kWh per square meter, and with water consumption varying between 15 and 75 liters per square meter. As for Almería type, the structure of the multi-span greenhouse and the irrigation system generate the greater impact. As a consequence of the greater use of metal in the construction of this greenhouse, the impacts are generally higher than those of the first case, the Almería type, with emission between 115 and 1,000 kg of CO2 equivalent per ton of vegetable produced. The last case selected to characterize Spanish greenhouse are the heated multi-span, that represent less than 2% of the greenhouse of Spain. The cost of this type of greenhouse varies from 14.5 to 15.8 euro per square meter. The use of heating allows increasing productivity about 20 kg per square meter. The highest production cost is natural gas for heating, around 14%. Depending on the price of fuel and vegetable, farmers can earn or lose money. As in the previous case, if the average sale price is considered, it is normal to obtain loss. Farmers generally sign contracts directly with supermarket chains to ensure a profit of their production. The use of the heating system increases energy consumption about 120 kWh per square meter. Water consumption can also increase due to the greater transpiration of the crop, with value of 150 liters per kilogram of vegetable. The use of heating system also significantly increased emission to value of 3,500 kg of CO2 equivalent per ton of vegetable produced. The first case study selected in Italy is the multi-span greenhouse with a heating system. Its cost varies between 20 and 18 euro per square meter. In this greenhouse, production is not very high, so many farmers opt for high-value crops such as tomato or cherries. As in the case of Spain, the high investment requires farmers to ensure sale price higher than average to avoid incurring loss. Energy and water consumption are very similar to those of inhabited multi-span greenhouse in Spain. However, the cost of water of approximately 0.25 euro per cubic meter is much lower than in Almeria. The metal structure of multi-span greenhouse generates emissions between 715 and 1,200 kg of CO2 equivalent per ton of vegetable. The last case selected corresponds to a heated greenhouse in Italy with a high level of technology in climate control system. The cost of this greenhouse is the highest, with value of 70 to 160 euro per square meter. In this greenhouse, the cost of energy for heating represents between 20 and 14% of the total cost. Heating allows increased production above 15 kg per square meter. The economic risk is greatly increased, so both profit and loss can be much greater than in a heated greenhouse. Energy consumption for heating is much higher in this greenhouse, between 9 and 13,000 gigajoules per hectare, than those required in Almeria, where there are a more temperate climate. This greenhouse generates the highest environmental impact, with emission of around 1,400 kg of CO2 equivalent per ton of vegetable production. The main conclusion obtained from this case study is that in heated greenhouses of Spain and Italy, thermochemical fluid could be used to reduce the cost of energy of heating and to reduce their environmental impact. The climate control system based in thermochemical fluid could be also used in a heated multi-span greenhouse to cooling and to humidity control. The medium-large size companies are the most susceptible to incorporating this type of technology in Spain. The farmers consulted indicate that they will make an investment of 5,000 to 15,000 euro per hectare with a return period of 2 to 10 years. Thank you very much for your attention, and you can contact by mail with me for additional information about the case study of the TheGreefa project.